There are roughly 200 billion stars in our galaxy alone. Sit with that number for a second. Not because it's big, you've heard big numbers before, but because of what it seems to promise. 200 billion suns, many of them older than ours by billions of years. Some of them were shining, steady and bright, before our sun had even finished forming out of its cloud of dust. And around a great many of them, planets, warm ones, wet ones, planets sitting in that comfortable band where water stays liquid, where chemistry gets interesting, the Goldilocks zone, we call it. Not too hot, not too cold, just right for the slow, patient business of life getting started. So here is the question that has been quietly eating at thoughtful people for 100 years. If the universe is this vast, this old, this generous, with the ingredients, where is everybody? You'd expect a crowded sky. You'd expect signals. You'd expect visitors. You'd expect the night to be full of chatter, the way a great city hums even at 3 in the morning. Somewhere, someone is always awake in a city. Somewhere, a light is always on. That's what you'd expect from a galaxy this size. Instead, silence, a deep, patient, total silence. Most people assume that silence is temporary, that we simply haven't looked hard enough yet, or that the aliens are shy, or that first contact is scheduled for some Tuesday next century once our technology grows up a little. That's the comfortable story. It's the story every film tells you, and I want to gently take it apart, because I think the silence isn't an accident. I think it isn't shyness, and it isn't bad luck, and it isn't a technology problem we'll solve with a bigger antenna. I think the universe itself enforces it, not through some cosmic police force, not through any rule against life, through something far more stubborn than any of that, through arithmetic, through the plain, unfeeling numbers of distance, time, and speed. That's a strange claim. I know how that sounds. So we're not going to take my word for anything. Not one thing. We're going to reason it out, step by step, from your armchair, using nothing but numbers you can check and logic you can follow. And by the end, I think you'll see the sky differently. Not emptier, different. Sit with that. Before we can ask whether contact is possible, we have to ask a harder question. A question that comes first. How do we know anything about the universe at all? Because we can't visit it. Let's be honest about that up front. We've sent human beings about as far as the moon. That's it. That's the whole record of human travel. A 3-day trip to a rock 250,000 miles away. Everything else, every star, every galaxy, every claim anyone has ever made about what's out there, we've learned by sitting here and catching light. That's worth pausing on, because it changes everything that follows. All of our cosmic knowledge arrives as light, old light. Light that left its source long ago and traveled across an emptiness so wide that the numbers stop meaning anything unless we build them up carefully, one honest step at a time. So let's build one up. Light moves at about 300,000 kilometers every second. Hold that. 300,000 kilometers. And not per hour, not per minute, per second. In 1 second, light could circle the entire Earth roughly 7.5 times. 7.5 laps of the whole planet. In the time it takes you to say the word light, that's fast enough to feel instant here on the ground. Flip a switch, the room fills, done. You will never in your life notice the delay. Speak to someone across the dinner table, and the light bouncing off their face reaches your eyes in a fraction so small no clock you own could measure it. Now stretch it. Push that same speed out into space and watch what happens. It takes light a little over a second to reach us from the moon. So when you look up at a full moon, you're seeing it as it was 1 second ago. A tiny delay, but a delay. Light from the sun takes about 8 minutes to reach us. 8 whole minutes. Which means if the sun simply blinked out, vanished, you would carry on in perfect sunshine for 8 more minutes, entirely unaware, before the darkness arrived. You'd be living in the past without knowing it. That's the first taste of what's coming. Now stretch it further still. In 1 year, light travels a distance we call a light year. Write that distance out in kilometers, and it's about 9.5 trillion. 9 followed by 12 zeros. A number you cannot picture, and neither can I, and I'd be lying if I claimed otherwise. So don't try to picture it. That's the wrong instinct. Just hold on to what it means. A light year is a distance so large that light itself, the fastest thing there is, the thing that laps the Earth 7.5 times a second, needs a full year to cross it. A whole year, racing the entire time, never resting, never slowing. The nearest star to our sun sits a little over 4 light years away. Let that settle. 4 of those unimaginable distances, stacked end to end, just to reach the closest neighbor. That means the light hitting your eye from that star tonight left it more than 4 years ago. Think about where you were 4 years ago, what you were worried about, who you spoke to. That light was already on its way, already crossing the dark before any of it happened. You are not seeing the star. You are seeing its past. A 4-year-old photograph developed and delivered by the universe free of charge, and there is no faster mail service anywhere in existence. Look further, and it gets stranger and better. The light from some galaxies has been traveling for billions of years before it reached the mirror of a telescope. When that light first set out, the Earth did not exist. There was no Sunday. There was no solar system. The atoms that would one day become you were scattered somewhere else entirely, spread across other stars that had not yet died to release them. So when we look deep into space, we are not looking out, we are looking back. This is the fact I most want you to hold. Distance and time are the same currency out there. The further away a thing is, the older the news you're reading about it. To look far is to look into the past. There is no other option. This is the first thing you have to make peace with. And it took clever people a long while to make peace with it themselves. We do not observe the universe as it is. We observe the universe as it was. There is no way around this. None. It's not a technology problem we'll fix with a better telescope or a sharper camera or another century of engineering. It's built into the fabric of things, into the structure of space-time itself, that single woven thing that space and time turn out to be. Light takes time. Space is enormous. The past is all we ever get. And once you accept that, half of tonight's argument is already sitting quietly in your lap. And there's a floor to what we can know, an actual bottom. Go back far enough to when the universe was very young and very hot, and you hit a wall of light left over from the beginning of everything. We call it the cosmic microwave background, a faint glow filling the entire sky. In every direction you point, the oldest light there is. It's the afterglow of the young universe cooling down. And before it, the universe was too dense and too hot for light to travel freely at all. Light couldn't move in a straight line. It just scattered, trapped, like trying to see across a room full of thick fog. So we simply cannot see further back than that glow. It's a horizon, an event horizon of a kind, a boundary pass which no information can reach us, not because our instruments are weak, because there is nothing to see behind it. The information doesn't exist for us. It never will. I find that thrilling rather than frustrating, and I hope you'll come to feel the same. It means knowledge here has edges, real edges, and honest people can walk right up to them and point and say, here, this far and no further. Not everyone gets to know exactly where their ignorance begins. In this game, we do. We have mapped the shape of our own blindness. That's a rare and beautiful thing. Now, when a telescope like James Webb looks at the faint red smudges of the earliest galaxies, the ones that formed when the universe was young, it's using the same principle we've just built. The light from those galaxies has been stretched on its long, long journey across expanding space, stretched toward the red end of the spectrum, the way a siren drops in pitch as it races away from you. You've heard that an ambulance passing, the note falling as it goes. Light does the same thing when its source is rushing away, only it shifts in color rather than sound. We call that redshift, and it's not a curiosity, it's a ruler. The amount of stretch tells us how far, and therefore how long ago. The redder the light, the longer the trip, the older the story. Webb is quite literally a machine for reading old light very carefully. And some of what it's found, galaxies that seem to have grown up faster and fuller than we expected in the early universe, galaxies that look too mature for how young the cosmos was when their light set out, is exactly the kind of surprise that keeps this whole enterprise honest. It means our neat story had a gap in it. And a gap you can point to is a gift, not a failure. So we have tools, good ones, extraordinary ones. But notice what kind of knowledge they give us, because this matters for everything ahead. Patient knowledge, indirect knowledge. Knowledge always about the past, always bounded by the speed of light and the size of space. We are not eyewitnesses to the cosmos. We are historians of it, reading letters that took eternities to arrive. And a historian, however brilliant, never gets to shake the hand of the person whose letter she reads. Hold on to those two facts as we go. Everything we know comes as light, and light is slow, painfully, stubbornly slow compared to the distances involved. That's not a detail you can set aside. That's the whole game. That's the engine of everything that follows. Keep those two facts close, because the silence we started with is going to grow directly out of them like a plant from a seed you can already see in the ground. Let's do a thought experiment, a simple one. You don't need any equipment except your imagination and a willingness to be honest about numbers, even when they disappoint you. Imagine there's a civilization out there that wants to reach us, not signal us, not wave from a distance. Reach us, send a ship, arrive. They're friendly, they're capable, they're determined, and crucially, they exist right now in a way we could meet. Let's give them every advantage we possibly can. Let's stack the deck wildly in their favor. Let's assume they live at a nearby star, one of the very closest ones, just a few light years away. And let's ask a plain, fair question. How long does the trip take? First, they have to leave home. Before anything else, they have to get off their planet, and that's already a fight. To leave any planet, you have to beat its gravity. There's a speed you must reach, we call it escape velocity, below which you simply fall back down, no matter how much you'd rather not. For Earth, that speed is about 11 kilometers per second, fast, far, far faster than a rifle bullet, faster than anything you've ever watched move. Imagine crossing the length of an entire city, end to end, in a single second, and you're still not quite there. And here's the sobering part. That only gets you off the planet. That's the entry fee. It does nothing, nothing at all, to get you across the gulf between stars. You've paid enormous energy just to reach the front porch of space. You've opened the front door. You haven't taken a single step down the road. So now they're in space, coasting, free of their world. How fast can they go from here? And here we hit the wall, the real one. There is a cosmic speed limit, and it is the speed of light. Nothing carrying information or mass reaches it, let alone passes it. Not a ship, not a signal, not a particle, not a wish. That's not a rule we invented to be annoying. It's woven into space-time itself, and every single experiment we have ever done across more than a century of trying to catch it out agrees. We have thrown particles at that limit as hard as we know how in the largest machines we've ever built, and they simply refuse to cross it. They get heavier and more stubborn the closer they get, as if the universe itself leans back against them. So light speed is the ceiling, the absolute best case. The dream scenario we'll be generous enough to imagine, even though we've never come remotely close. Let's be wildly generous and pretend they can travel at 1/10 of light speed. I want to underline how enormous a gift that is. We have no idea how to do that, not remotely. Our fastest spacecraft ever built manage a small fraction of 1% of light speed. To reach a 1/10 of light speed, you'd be moving at 30,000 kilometers every second, fast enough to cross the entire Earth in less than half a second, fast enough to travel from here to the moon in about 13 seconds. We cannot do this. Nothing we've ever made comes within 1,000-fold of it, but let's just hand it to them anyway. 1/10 of light speed, a staggering fantasy speed. Fine. At that speed, a journey of 4 light years takes 40 years. One way, do the arithmetic yourself if you like a 1/10. The speed of light means 10 times as long as light would take, and light takes 4 years. So 4 decades sealed in a metal can, crossing an emptiness with nothing to stop at, nothing to see but the same stars barely shifting. A child born at launch would be middle-aged before arrival. Their parents, the ones who chose to go likely dead along the way. And remember, that's from the nearest star at a speed we can't remotely achieve, and we're ignoring the fuel problem entirely. And the fuel problem is not a footnote, it's a monster. To push something up to 1/10 of light speed, and then this is the part people forget to slow it down again at the far end, you need staggering amounts of energy. Twice, really. Once to speed up and once to brake. Because arriving at 1/10 of light speed isn't a visit. It's an impact. It's a weapon, not a guest. At 30,000 kilometers a second, a ship doesn't land, it detonates. So you have to carry the fuel to decelerate, which means carrying more fuel to accelerate the fuel you'll need to decelerate, and then more fuel still to accelerate that fuel, and the numbers spiral into something that dwarfs the entire energy output of a planet. The faster you want to go, the more brutally the arithmetic punishes you. This isn't an engineering hurdle we'll clear with cleverness. It's a cliff that gets steeper the higher you climb, and nobody has ever found the top of it. Here's the turn. And it's the turn that quietly ends the whole fantasy. Most stars are not 4 light years away. The nearest one is the lucky exception, not the rule. Most stars in our galaxy are hundreds of light years away, thousands, tens of thousands. Our galaxy is about 100,000 light years across, edge to edge. So if a civilization lives on the far side of the galaxy, still our own galaxy, still our own cosmic backyard, not even a hop to the next galaxy over, then even at that impossible 1/10 of light speed, the crossing takes 1,000,000 years. 1,000,000 years for a single one-way trip inside one galaxy. Say that number slowly. Sit with what that does to the very idea of contact. It's not that it's hard. Hard is climbing a mountain. This isn't hard. It's that the distances are so large that the word visit stops meaning anything at all. You don't visit across 1,000,000 years. A civilization that launched such a ship would be long gone, evolved into something else, or scattered, or simply extinct before it ever arrived. Think of 1,000,000 years of your own species' history. We were not remotely ourselves 1,000,000 years ago. We were something that couldn't speak, couldn't write, couldn't dream of stars. The senders and the arrivers would not be the same people, the same culture, the same technology, perhaps not even the same species. The ship becomes a message from the dead, arriving for strangers, a time capsule launched by a world that no longer exists, delivered to a world that has forgotten it was ever sent. So the implication lands quietly, and it lands hard. The silence might not mean nobody's home. It might mean the rooms are simply too far apart to walk between. Not forbidden by any law against life existing, not forbidden by hostility or shyness, forbidden by the plain indifferent size of the house. Let me try a second thought experiment. Set the first one completely aside. Forget ships, forget fuel, forget the impossible metal cans crossing the dark. Let's say nobody ever comes to visit anybody. Ever. Fine, grant it. Surely they can still talk. Talking is cheap. Light itself carries no fuel problem. Radio waves are just light we happen not to see with our eyes, and they cross space at the full speed limit for essentially free the moment you flip the transmitter on. No metal can, no fuel spiral, no deceleration nightmare. Just a signal released into the dark, moving at the fastest speed the universe permits. So let's send messages instead of ships. Let's be sensible about it. This feels much more promising, and genuinely, it is. It's the right idea. This is exactly what we've spent decades doing, listening for signals and occasionally sending them. It's promising right up until the moment you look at the clock. And then the same monster we met before turns up wearing a different face. Picture two civilizations, us and them. They're at a star 500 light years away. And I want you to keep in mind, that's still very close by galactic standards. 500 light years is a tiny corner of a galaxy 100,000 light years wide, practically next door. A neighbor so close on the galactic scale that you'd wave to them over the fence. They send us a friendly hello encoded in radio, beamed right at us on purpose, aimed with great care at our little yellow star. How long until it arrives? 500 years. Because the message travels at light speed, and they're 500 light years off. And here's the thing you already learned. Those are the same statements said two ways. A light year of distance is a year of delay. always, without exception. The message left when, on Earth, people were still seriously arguing about whether the sun went around the Earth or the other way around. Whole empires have risen and fallen while that hello was in transit. Languages have been born and died. Great cities have turned to ruins and been dug up again. And now finally, after all of that, it arrives. We hear it. Wonderful. Delighted. Thrilled. We reply. Hello back. We beam it straight at their star. Off it goes at light speed, the fastest anything can move. And it arrives at their star 500 years from now. So the round trip, one hello and one hello back, takes 1,000 years. Stop and truly feel that. A single exchange. 2 sentences. Hello and hello back. 1,000 years. That is not a conversation. Nobody would call that a conversation. That's a message in a bottle thrown into an ocean so wide that the bottle outlives everyone who ever touched it. On both shores. The one who threw it and the one who might one day find it will never know each other's names. They will never know if the other was kind or clever or afraid or curious. They will only know that once, across an impossible distance, someone said hello. And remember, 500 light years is the generous case. That's a close neighbor, handpicked to flatter the argument. Push the distance out to something more typical for our galaxy, tens of thousands of light years, and a single hello and reply takes longer than the entire span of human recorded history, longer than writing has existed. You would need a civilization that stays stable, curious, technologically capable, and pointed patiently at the exact same faint patch of sky for 100,000 years, just to complete 2 exchanges. 2, not a discussion, not a debate. 2 words spread across 100 millennia. Ask yourself honestly whether we could manage that. We've had trouble staying pointed at anything for 100 years. Governments change, priorities shift, budgets vanish. The instrument gets old and nobody funds a new one, and that's just us, one restless species over one restless century. Here's the turn, and it's sharper than the last one because it adds a second blade. It isn't only about distance anymore, it's about overlap in time. For 2 civilizations to actually talk, they don't just need to exist somewhere out there. They need to exist at the right times, offset from each other by exactly the light travel gap between them, and both need to last long enough to catch the reply. Both windows have to be open, and open in the correct relationship across an ocean of years. That's a fearsomely narrow target. It's not enough to share a galaxy. You have to share a moment, and the moment can be 1,000 years wide and still be far too small. Think about how briefly we've been able to do this at all. Really think about it. We've had radio for about 100 years. Barely. A single human lifetime, roughly, 100 years, set against a universe that's nearly 14 billion years old. Let me put that in proportion, because proportion is the whole point. If you squeeze the entire history of the universe into a single year, with the beginning on the 1st of January, then all of human radio, every broadcast, every signal we've ever sent or listened for would occupy the final fraction of the last second before midnight on the 31st of December. A blink inside a blink. Our window of being technically capable of listening and speaking is a razor-thin sliver, a flash. A spark struck in the dark and, for all we know, soon gone. If most civilizations have similarly thin windows, a few centuries of radio, say, before they change into something else, or go quiet, or move to some technology we wouldn't recognize as a signal at all, then the odds of 2 windows happening to line up across exactly the right distance, at exactly the offset the light travel time demands, become vanishingly, heartbreakingly small. This is really the beating heart of what the Drake equation and the Fermi paradox are pointing at. Once you strip away the mystique, the Drake equation isn't a magic formula. It's just an honest way of multiplying together all the things that would have to be true for us to hear someone, how many stars there are, how many of those have planets, how many of those planets could host life, how many actually do, how many of those develop technology, and then the last term, the quiet assassin that kills the whole hopeful sum, how long that technology lasts and keeps broadcasting. Every earlier term can be generous, wildly generous. You can fill the galaxy with planets. You can let life spring up on every warm and wet one. You can hand technology to every living world. And that final term, if it's small, drags the answer all the way down towards zero anyway. It's like multiplying a fortune by a fraction so tiny that whatever you started with, you end with almost nothing. The Fermi paradox is simply the plain observation that follows. When you naively expect a crowd, you find an empty room. Named after the physicist who supposedly asked, over lunch, the same question we started with. Where is everybody? And the implication here is almost gentle and almost sad. The galaxy could be teeming with voices, genuinely, gloriously full of them. Thousands of civilizations, each one certain it can't be alone, each one looking up and wondering exactly what you're wondering right now. And we could still hear absolutely nothing. Not because anyone is hiding, not because we're being quarantined, because their hellos left before we could listen, or will arrive long after we're gone, or are crossing the void right now, this very second, aimed with great care at a version of Earth that simply won't exist by the time they land. Talking is free, timing is not, and the universe is stingy miserly, really, with timing. There's a third thing worth sitting with, and it's my favorite, because it comes from something real, something that actually passed through our neighborhood that we actually watched. Not a story, not a thought experiment, an observation, logged and argued over by people who do this for a living. In recent years, we've caught a small handful of objects falling through our solar system that did not belong to it. Genuine outsiders. And we can tell they're outsiders, we're not guessing, because of how they move. Everything born alongside our sun orbits it in loops, bound to it by gravity, patiently following the neat, ancient rules of orbital mechanics, the arithmetic of how things swing around one another in space. The same arithmetic that keeps the planets in their lanes and the comets on their long returns from the deep freeze of the Kuiper Belt, that ring of icy leftovers out past the last planet. But these particular objects came in on paths too steep and too fast to be bound to anything. They weren't looping. They fell in from the dark between the stars, whipped once around the sun, and left forever, never to return. Interstellar objects, we call them. Genuine visitors from around another star, just passing through our patch of the void. Think about that for a moment. A piece of another solar system formed around another sun, under another sky, tumbling silently into ours. The first one we studied well was nicknamed Oumuamua. And here is where it gets delicious. As it swung away from the sun and headed back out, it sped up just slightly, a little more than the sun's gravity alone could account for. A tiny non-gravitational acceleration, a faint nudge from something other than pure gravity. A whisper of extra push that shouldn't quite have been there. Not much, not dramatic, but measurable. Enough to make careful people frown at their screens and check the arithmetic twice. Now, the boring explanation, and almost certainly the correct one, is that it was quietly venting gas as it warmed near the sun, the way a comet does, and that gentle, invisible jet gave it a small shove. A comet is essentially a dirty snowball. And when a snowball gets warm, it steams. That steam pushes back softly, like the faintest breath against your palm. That's Occam's razor doing its steady work, the principle that you reach for the ordinary cause before the extraordinary one, that you don't summon a miracle when a puff of gas will do. And since then, we've watched other interstellar wanderers, like the one cataloged as 3I, Atlas, and studied each with that same careful, unhurried, skeptical eye, reaching for the dull answer first, as we should, testing it, trying to break it. That's the discipline. That's what keeps us honest. When a wilder idea comes knocking, but for a while, a few serious and thoughtful people asked a wilder question, and it's genuinely worth asking right alongside them, precisely because of where the reasoning leads, not where you assume it will. What would have to be true for that little nudge to be something built? For the object to be a craft? A probe? A sail catching sunlight? A machine sent on purpose from somewhere far away? It's a fair question to put on the table, not to believe, to test, because a good idea and a wild idea are told apart the same way by asking what would have to be true and then going to look. And here's the turn, and it is not the turn you're bracing for. Even if it were even granting the wildest version that one of these things had been a genuine probe, a sail, a deliberate machine from another civilization, look at what it actually did. It didn't stop, it didn't signal, it didn't slow and settle into a tidy orbit to have a look at us. It didn't so much as blink. It fell through, utterly silent, and left at tremendous speed, on a path that in a few short years carries it back out into the permanent dark, gone from us forever. No message, no pause, no sign that it knew we were here at all. That's the lesson hiding inside the real data. Whatever these objects finally turn out to be, and I'd bet on gas and rock every time, even direct physical contact with something from another star, an actual solid object from another solar system, present in our own sky, close enough to photograph and track, gives us almost nothing to hold. A blur, a trajectory, a faint anomaly in its motion that careful people will argue about for decades, and rightly so. It does not wait for us. It cannot wait for us. It's moving far too fast, and the whole encounter is over in a matter of weeks. Here and then gone. Before we've finished pointing our instruments at it, we barely got a good look before it was already on its way back out. We caught a glimpse. That's all the universe offered. A glimpse, and then the door closing. This is the Copernican principle in action. By the way, the deeply humbling, deeply useful idea that we are not special, not central, not the intended audience of anything the cosmos does. The sun doesn't orbit us. The galaxy doesn't revolve around our concerns. And an interstellar object certainly isn't coming to see us. We just happen to be standing near the road when it hurtles past. That's all. It's the same lesson we've had to learn over and over every time we assumed we were at the center and found we were not. The Earth isn't the center. The sun isn't the center. Our galaxy isn't the center. There is no center. And an object passes so quickly and so completely silently that even a genuine artifact from another civilization could sail clean through our solar system and leave us with nothing but a question mark and a few grainy images to fight over. So sit with the implication of that, because it rearranges something. We've always imagined contact as a landing, a meeting, a ramp lowering, a handshake, a face. Every film sells you the same scene. But the one and only form of real interstellar contact we've actually experienced, the genuine article, matter from another star touching our own space, looks like this instead. A fast, mute stone tumbling through the dark, gone before we understood it. The universe let something from another star reach right into our neighborhood, close enough to study, and still silence. Not a refusal, not a snub, just physics. Just speed and distance doing exactly what they always indifferently do. The visitor didn't ignore us. It simply couldn't do anything else. Let's bring the three together now, because here's the thing. They were never three separate problems. They're one single problem wearing three different coats. The first said, ships can't reach us. The distances are so vast, they turn any voyage into a journey far longer than the lifespan of the civilization that dared to launch it. The traveler outlives the sender's entire world. The second said, messages can't reach us in time. Talking is free, gloriously free, but the round trip outlasts everyone involved on both ends, and the narrow windows of listening almost never overlap across the gulf. The third said that even when something real does fall into our neighborhood from a genuine other star, it passes far too fast and far too silent to count as contact at all. Notice the single thread running through all three, tying them into one knot. It isn't hostility. Nobody out there is our enemy. It isn't hiding. Nobody is ducking behind a moon. It isn't some galactic law forbidding us from meeting our neighbors, some cosmic rule handed down against us. It's the same two numbers every single time in every single case. Space is too big, light is too slow. That's it. That's the entire enforcement mechanism laid bare. There's no wall built around the earth. The wall is the shape of space-time itself. The wall is the size of the room. And here's what I find genuinely breathtakingly beautiful about this, rather than bleak, and I hope you'll come with me on it. The silence is not evidence of an empty universe. Read that again in your mind, because almost everyone gets this exactly backwards. The silence tells us almost nothing about whether life is out there. Next to nothing. What it tells us everything about is the medium the messages have to cross. A universe absolutely packed to the seams with life would sound exactly as quiet to us as a completely empty one. Exactly as quiet. The distances erase the difference entirely, swallow it whole. The silence is not the sound of no one being there. It is the sound of the gap between us and everyone. It's the sound of the size of things. Let that flip settle in your mind, because it changes what the quiet even means. Quiet was never the absence of company. Quiet is just what distance sounds like. Think about what that means for all our searching. And it's worth thinking about carefully, because it's not an argument to stop. We look for a biosignature, a chemical fingerprint of life, something like oxygen or methane, in the wrong proportions, in the thin atmosphere of a distant exoplanet, a planet around another star. We split the starlight that has passed through that atmosphere and read the colors missing from it, because each gas swallows its own particular shades, and the gaps tell us what's there. We look for a technosignature, a sign of technology, a stray radio leak, an artificial glow on a night side, a chemical that only industry makes and nature never does. And it's worth doing. It's among the most thrilling things our species has ever attempted, and I would not stop for anything. But be clear-eyed about what even a triumphant success would be. Even a clear, undeniable detection would be a detection of the past. A world as it was hundreds or thousands or millions of years ago, depending on how far we would be reading a letter, not meeting a writer. And by the time we finished reading it, the writer might be long changed, or long silent, or long gone. That doesn't make it worthless. A letter from the dead is still a letter. It might be the most precious letter ever read. It just isn't a handshake, and we should stop expecting a handshake. There's something almost nobody sees here, and I think it's the real key to the whole night. The barrier isn't truly a barrier of space. It's a barrier of time, wearing space as a disguise. Every light year of distance is precisely a year of delay. They are the same thing seen from two angles. So the further away a civilization is, the more certain it becomes that we and they simply do not exist in the same usable window of time. The galaxy could be a vast concert hall, packed and roaring, every instrument playing at once, and we could be sitting right in the middle of it, hearing nothing at all, because the sound from the far seats takes 100,000 years to cross the room, and no player alive holds a single note that long. By the time the music from the back row reaches you, the musician has been dust for 1,000 generations, and your own playing won't reach them until long after you've put down the instrument for good. That's the convergence. Three arguments, marching in from three directions, arriving at one conclusion. Contact in the way we've always dreamed it, a two-way meeting between minds. In real time, question and answer, face and face is not merely difficult. It is effectively ruled out by the sheer size and speed of the cosmos for very nearly any two civilizations that aren't practically next door and aren't almost impossibly well-timed to boot. The universe enforces its silence not with a lock and not with a guard, but with a distance so vast that the key would take longer to turn than any hand survives to turn it. So, let's bring it home. Let's gather the whole thing up. We started with a number, 200 billion stars in our galaxy, generous with warm planets, and a sky that stays stubbornly quiet anyway. And we asked the oldest fair question there is, the one over the lunch table, the one that won't let thoughtful people sleep. Where is everybody? We began by being honest about how we know anything at all. That was the ground we had to stand on before we could take a single step. Everything we learn about the cosmos comes to us as light, and that light is always old news, because it takes real time to cross the enormous distances involved. The sun you see is 8 minutes old. The nearest star is 4 years of light away. The faint galaxies are billions of years stale by the time they reach us. We never, ever see the universe as it is, only as it was. That's not a flaw in our telescopes we'll one day repair. It's the deep nature of looking across space, where distance and time turn out to be the very same currency, spent the same way. Then we ran 3 thought experiments, and every one of them pointed the same direction, like 3 compass needles swinging to the same north. We imagined a ship, and we found that even at 1/10 of the speed of light, a speed 1,000 times beyond anything we can build a trip across our own single galaxy, takes 1,000,000 years, long enough that the travelers and the ones who launched them are no longer the same people, no longer the same anything. Travel doesn't connect civilizations across those gulfs. It outlives them. It buries them. We imagined a message instead: cheaper, faster, free of the monstrous fuel problem. And we found that a single hello in reply to a close neighbor cost 1,000 years, and to a typical galactic distance cost longer than all of human history laid end to end. And worse, both sides have to be listening in windows that line up across that yawning gap. And our own window, a single century of radio against 14 billion years of cosmos, is a mere flicker, the last fraction of the last second of the cosmic year. 2 flickers at the right distance, at the right offset, happening to line up. That's not conversation. That's a coincidence so rare, it barely deserves the name hope. And then we looked at something real, the interstellar objects that have genuinely fallen through our solar system, with their faint non-gravitational nudges that careful people still argue over in good faith. And we found that even actual physical contact with something from another star hands us almost nothing: a blur, a trajectory, a fast stone in the dark, gone before we understand it. The Copernican principle, quietly at work. Nothing comes to see us. Things merely pass far too fast to greet, indifferent to whether we're even watching. 3 coats, 1 body underneath. Ships fail by distance. Messages fail by time. Objects fail by speed. And beneath all 3, holding them up, the same 2 stubborn, unfeeling facts we found at the very start. Space is too big. Light is too slow. Which brings us right back around to the silence, and to the one thing above all I want you to carry away from tonight. That silence is not proof of an empty universe. It never was. A universe overflowing with life would sound just as quiet to our ears, because the gap between the seats swallows every voice before it can cross. The silence is not the absence of neighbors. It is the presence of distance. It is the universe enforcing, through nothing more than pure arithmetic, a solitude that no one chose, that no one intended, and that no one, no matter how clever, how kind, how determined, can break. Now, let me be honest about the edges, because the honest answer is where the real wonder actually lives. And I'd be cheating you badly if I pretended the case were airtight and sealed. It isn't. No good idea is. And an idea that can't tell you how it might be wrong isn't really an idea at all. It's just a belief. Wearing a lab coat, everything I've said rests on the speed of light being the true and final ceiling. And it is as far as every experiment we have ever done over more than a century can possibly tell. But as far as we can tell is a real boundary, an honest one, not a certainty carved in stone. If there were ever some way to move or to signal that sidestepped that limit, and I want to be as clear as I possibly can, we have no evidence for it, no working mechanism, not even a serious testable hint that such a thing exists, then this whole argument loosens at the joints. I don't believe there is such a way. Nothing in the evidence points to one. Every time someone thought they found a crack in that ceiling, a closer look sealed it right back up. But an idea is only ever as strong as the observation that could kill it. That's what makes a claim falsifiable. That's what separates science from wishing. And so I owe you that door, left honestly ajar, not slammed shut for comfort. There are other loose threads too, and I won't hide them. We've talked as though we know how to recognize a signal, but we might not. A civilization far older than ours might communicate in ways we'd never think to call, communication patterns in light we read as natural, or channels we haven't dreamed of. We might be swimming in messages and calling them background noise, the way someone who's never heard a language hears only sound. And there's dark matter, that invisible stuff that seems to outweigh everything we can see, bending starlight through gravitational lensing. so that distant galaxies smear and double behind it. A plain reminder that most of the universe is something we can't yet even name, let alone rule things out about. When most of the cosmos is still a mystery, humility is not just polite, it's required. The timing argument, too, rests on a guess we cannot yet check. How long do technological civilizations last, and how loudly do they broadcast? We have exactly one example to reason from: ourselves. And we're 100 years into it, if that. You cannot build a reliable statistic out of a single data point. You can barely build a hunch. Maybe civilizations routinely last millions of years and drape the sky in signals we simply haven't learned to recognize yet. Maybe we're surrounded by messages we're reading as noise that would change every one of the odds enormously in a heartbeat. We simply don't know yet. And I want to insist on this. We don't know yet is not a failure or an embarrassment. It's the most exciting sentence in the entire language, because it means the sky still has something left to tell us, and we're still young enough to hear it. The mystery isn't a gap in the story. The mystery is the story. Those are the open edges drawn as plainly as I can draw them. I wanted you to see exactly where they sit and exactly how far the boundary of the honest answer really extends. No further and no less. That's the whole of scientific literacy, really not knowing all the answers, but knowing precisely how sure you're allowed to be, and being willing to say so out loud. So here's where we land, you and I, at the quiet end of all this. The night sky isn't empty, and it isn't hostile, and it isn't hiding anything from you out of spite. It's just vast, vast in a way that quietly turns distance into time and time into silence without ever meaning to. And I think there's something quietly magnificent in that. Once it settles, we are not alone because no one else is there. We may be alone because the universe is so wildly, extravagantly generous with room that everyone gets a corner too far from everyone else to shout across. Solitude by abundance, silence made not of emptiness, but of sheer, staggering space. Isolation as a side effect of a universe too big to be lonely in together. And yet here we are. Think about this last thing with me. A small, warm, curious species sitting on one ordinary planet, circling one ordinary star, out on one arm of one galaxy among hundreds of billions of galaxies, and we worked all of this out from our armchairs without leaving home, by catching old light and reasoning carefully, honestly, stubbornly about what that light can and cannot carry to us. We measured the size of a house we can never walk across. We charted the shape of a silence we can never break. We may never shake a hand across the dark. We may never hear a single reply, but we figured out precisely why. And figuring out why, from right here, with nothing but these borrowed minds and this patient reasoning, is its own kind of contact. Contact not with a neighbor, but with the shape of reality itself. And that, I'd argue, is the more astonishing thing anyway. That's the cosmic perspective I hope stays with you tonight, long after the screen goes dark. Look up and understand that you are not looking into an empty room. You are looking into a house so unimaginably enormous that its silence is the loudest, truest thing it could possibly say to you. And you, sitting there, are the part of that house that finally learned to understand what the silence means. If sitting with these ideas was worth your time, and I truly, genuinely hope it was, I'd be grateful if you'd subscribe and stay with us a while. There's no rush in it, and there is honestly nothing being sold here. Just more evenings like this one, working out the beautiful, stubborn, gloriously half-known universe together, one careful step at a time, from our armchairs, in no particular hurry. Thank you for spending this stretch of your one life with me. Genuinely. It means a great deal that you listened all the way to the quiet end.